Hey, good morning. Thank you for having me here. My name is Chung, and I'm having the privilege of working with more than 30 people on this Smart Forestry project, which is one of the OMTC's Oregon Mass Timber Coalition's projects. Well, for all of your great work, somebody has to provide wood, and that's what we're working on. Okay? And then, so especially we are looking at we are focusing on forest restoration work. Forest restoration means that it's like a fuel reduction thinning operation. It's not commercial clear cut. The operations that we do to mitigate wildland fire risks. Okay, so but the challenges of those treatments, the huge challenges we are facing, economic challenge, the costs of treatment, restoration treatments often exceed revenue. And also there is a lack of information about where to treat and how much volume we can get out of large landscapes. And then workforce issue, we have lost half of the logging workforce over the past 2 decades. We are losing people because logging job is known as difficult and dangerous. So we need to work on that. So to tackle these two challenges, that's the goal of Smart Forestry project. And then we formed these 5 task groups. 1 to 3, they are for addressing economic challenges. We want to improve efficiency of forest operations so that we can reduce the cost, as well as we can increase the revenue by producing mass timber out of small diameter trees as well. And then tasks 4 and 5, they're for workforce. We are developing workforce training programs, and also we're looking at how to improve workers' safety and health. So I have only 7 minutes, so I'm gonna just briefly mention about like 4 projects out of like 15 projects that we are working on. Okay, so first, the mapping solution. We are developing these new tools to identify where to treat and how much volume we can get, utilizing satellite imagery and ground plots together. So this is the example that we applied this tool to Umatilla National Forest. My graduate students over there, he did that. So Umatilla National Forest is about 1.5 million acres, and we applied this tool, and the result shows that over there, about 36% of the entire forests are in need of restoration right now, and then we can produce about 28 million cubic meters of softwood. And then not only that, we can also estimate volume per species and also per size class. So we can estimate up to 8-inch top logs, or up to 6-inch, or up to 4-inch top logs as well using this tool. And then next is a smart forestry operations task. We've been developing multiple new technologies and tools to improve the efficiency of forest operations, timber harvesting. One of the examples that I want to share with you today is this digital prescription. So the typical thinning, the results of typical thinning operations is right there. Okay, you can see the leaf trees after work. Leaf trees are distributed evenly across forest stand, but ecologists say that that is not ideal. Okay, this is more ideal condition because historic patterns of trees and forests that are fire adapted look like this. So national forests, several of them, try to implement this on the ground, but it is very difficult. It's almost impractical because we have to designate the location of clumps of trees, and then also each clump has different size, means that different number of trees. So we have to distribute those clumps like this. This is the criteria we have to meet. So it is not easy to plan and implement this kind of work. So we developed automatic process how to do this, and that is we start from this LiDAR stem map. So with LiDAR sensors, drone, we can generate easily this individual stem maps, so standing tree locations. We know that accurately, and then from there we drive all the possible basically candidates of leaf trees and clumps or locations and so on. So we developed optimization algorithm, and then this is the result. So before treatment, this is the overstocked stand. You can see a lot of standing trees there. And now after the treatment or the digital prescription applied, then this is the result. So you can see a lot of gaps and openings and the clumps of trees and different size of clumps as well to meet the criteria. Okay, so this is what we developed. So that means that now if we have this stem map, individual stem locations, then we can encode which trees to cut, which trees to leave. So individual stem here now has a cut or leave mark on the map. Perfect. Now, how can we apply this on the ground? That's another challenge. Because, as you can imagine, overstocked, dense forest, if you're in the woods, there are so many trees that look alike. And we oftentimes lost orientation, right? So how to do that? We developed this machine vision system, computer vision, AI, of course. And then what we are doing is, here's the LiDAR stem map encoded with leaf tree and cut tree. And then the machine has a stereo camera, sees only a few trees in front of machine, right there. And then we developed the matching algorithm, and then we can find where those trees the machine sees located on the map. Then now we know leaf tree, cut tree. Okay, so that's what we did here. And this is the example of, this is what our machine vision does right there. And then we tested this in the field, okay? And then this map is, next, yeah, this is the, so right here is the LiDAR stem map, individual trees encoded with leaf or cut. And then this is the set of trees the machine sees at a time. And we can find exact location of those trees on the map. Then this is what we can do. Now we can show this display to machine operators which trees you should cut, which trees you should leave. So this is what we've been working on. Okay. Next, another interesting project is the chainsaw guide bar. So we are developing a sensor to scan cross-section of wood at the time of cutting. Okay. So this is a prototype, but why do we do this? Because we want to estimate the area of late wood and early wood. Our hypothesis is that information is related to wood property, density, MOE, and so on. So there's two components in this project. One, we need to have, well, we have this image. Now we are developing machine learning, AI again, to identify those boundaries and measure the areas, late wood, early wood, and then trying to link that information to MOE and other wood products. If this is successful, then we know more about a single log at the time of cutting and producing in the woods. Next, we're looking at these exoskeletons to improve health and safety of timber fallers, especially forest workers. We surveyed, and then many of timber fallers, professional timber fallers, said that they experience low back pain and injury most frequently. So we looked at exoskeletons that can support low back muscle activities. And then we tried this in the lab here, like different cutting heights and so on. And our results is promising. So especially the middle position here, there is a positive impact of this exoskeleton. So exoskeleton actually reduces the low back muscle activities, so which is good. Okay. And then the last one, now workforce development. We've been developing lessons and classes for elementary schools, middle schools, and high schools and undergraduate students. Okay, so we developed this elementary school for elementary school lessons. This cross-laminated timber is interesting lesson. I participated in that, by the way. So we use the popsicle sticks and then glue them together, make a larger board, and then cross-glue them, making mass timber. And then students can test the strength of the mass timber. It's very, very interesting class, by the way. And also middle school, we developed some classes. And high school, we extensively using our machine simulators. So OSU now has 33 these machine simulators. We lend some of them to each high schools. And also we conducted the workshops as well. They love this, by the way, because they are same as computer games. Okay? This is a way to attract younger generations to our sector. Okay? And then for undergraduate students, we developed our own campus at OSU. We developed a certificate program so students can learn how to operate machines using simulator. And then during summertime, they they really operate real machines working with industry partners. And then we've been working with other community colleges to spread these programs as well. So with that, thank you very much.